Pluto made them come all close by. Pluto's circle crosses that of a couple of different planets. Pluto, the hard little planet outwardly at the extent of our nearby planetary association, is stirring up power on Earth. Continuous surveys recommend a conceivable issue with Neptune, raising issues among analysts and space enthusiasts. Key figures like Neil deGrasse Tyson and Michio Kaku have sounded alerts about the repercussions of this boundless event. Anyway, how did Pluto create to become on a collision course with its contiguous planet, and what should this cosmic clash suggest for life on Earth? Be a part of us as we unravel how something enormous essentially rammed into Neptune and how analysts have been left troubled by this colossal inconsistency. Pluto, once hailed as a planet, went through a change in its reputation, being renamed as a dwarf planet due to its irregular orbit. Despite this demotion, Pluto still fascinates and intrigues the cosmic nearby area. Later conjectures from respected analysts like Neil deGrasse Tyson and Michio Kaku have raised concerns about Pluto's course, suggesting a possible meeting with Neptune, indicating an approaching series of consequences between the two heavenly bodies that could have significant repercussions for Earth. Pluto's journey around the Sun stands apart because of its unique attributes within our nearby planetary system. Its orbit is significantly large, crossing a considerable number of astronomical units. Since its discovery in 1930, Pluto has yet to complete a full orbit around the Sun, adding to its mysterious nature. Its orbit is elongated and eccentric, a departure from the more circular orbits followed by the major planets. Furthermore, Pluto's orbit deviates by 17 degrees from the ecliptic plane, giving its path a more pronounced tilt compared to those of the major planets. The combination of Pluto's eccentricity and its tilted orbit adds layers of complexity to its trajectory. One prominent aspect is its periodic conjunction with Neptune's orbit. For about 20 years throughout each orbit, Pluto ventures closer to the Sun than Neptune, defying assumptions based on their different positions within the nearby planetary system. Delving deeper into Pluto's orbit, it is intriguing to observe that it is not a perfect circle, but rather an elongated one, suggestive of an oval shape. This unique orbit results in significant variations in Pluto's distance from the Sun throughout its journey. At its closest approach, Pluto comes within about 30 astronomical units of the Sun, while at its farthest point, it reaches more than 40 times the distance of Neptune from the Sun. Further, Pluto's orbit is tilted at an angle relative to the orbits of the major planets in our nearby solar system. This inclination not only adds to the complexity of its orbit but also plays a crucial role in its interactions with specific heavenly bodies, particularly Neptune. When Pluto encounters Neptune, their gravitational interactions alter their trajectories over time. The resonance between Pluto and Neptune highlights the dynamic nature of our nearby planetary group. Even as Pluto was once considered a solitary wanderer in the outer reaches, its close encounters with Neptune emphasize the interconnectedness of celestial bodies, each exerting gravitational forces that shape the paths of others. In recent years, advancements in observational technology have aided astronomers in fine-tuning Pluto's motions with remarkable precision. This has led to a deeper understanding of its orbit and its potential consequences for the stability of the outer planetary system. Even as the likelihood of a direct collision between Pluto and Neptune remains low, the possibility cannot be entirely ruled out, prompting continued monitoring and investigation by the astronomical community. Despite its modest size and distance, Pluto continues to command interest and curiosity among scientists and enthusiasts alike. The question arises, why hasn't there been a collision between Pluto and Neptune? The answer lies in the influence of gravity from major planets. Astronomers began focusing on Pluto's path shortly after its discovery, and its orbit puzzled them. Unlike most planets that stick to similar planes as they orbit the Sun, known as the ecliptic plane, Pluto stands out with its tilted and oval-shaped orbit. The mystery deepens when considering that Pluto's path crosses Neptune's. Despite these complexities, Pluto's orbit remains stable, demonstrating the intricate mechanics of space. Understanding how three celestial bodies interact gravitationally, like Pluto, Neptune, and the Sun, is a significant challenge. It's akin to predicting where they will go based solely on where they start and how they influence each other. For Pluto, this journey illustrates how its path, Neptune's path, and the Sun's influence interact in a complex simulation of libration and the VSOP variations. These factors help scientists resolve the big question of Pluto's orbit. A simulation is crucial for maintaining planets in their orbits. While Pluto crosses Neptune's path, it is at least 90 degrees away, preventing a collision. Libration ensures that even as Pluto approaches Neptune or other large planets, it stays well clear of their path, reducing the risk of an accident. The VSOP variations, named after scientists, explain why Pluto's orbit appears unpredictable but remains stable over time. Despite the chaos in space, certain patterns and rules keep things in order. These rules maintain Pluto's orbit stability, preventing collisions with Neptune or changes in its path. The possibility of orbital chaos demonstrates how a celestial body's trajectory is highly sensitive to its initial position, as exemplified by Pluto. Even minor changes in its position or speed can drastically alter its orbit over time. Scientists use computer simulations to understand how Pluto interacts with other celestial objects, like Neptune. By tweaking these simulations, they can grasp how small changes can impact Pluto's path in the long run. In the late 1990s, these simulations revealed intriguing aspects of Pluto's orbit, despite challenges that could undermine it. Pluto's orbit remains astonishingly stable over billions of years. This indicates that although Pluto's path may seem chaotic, its journey across the solar system follows a consistent pattern. Looking ahead at what could happen with planets like Pluto that have irregular orbits is challenging. These systems are so unpredictable that it's difficult to forecast what will occur over the long term. Simulations help us understand potential outcomes, but also show us that we cannot predict everything. This knowledge helps us better understand how our solar system works. Pluto's orbit illustrates how seemingly erratic orbits can be influenced by gravity and how objects move in space. Continuing to study these phenomena is essential as it helps us comprehend our position in the universe. When examining space, we realize that objects can be unpredictable, and Pluto's orbit is a perfect example of this instability. Pluto's orbit differs from those of other planets. It is more oval-shaped, meaning it is not a perfect circle. At times, it even comes closer to the Sun than Neptune does. This adds excitement since Neptune is also moving along its orbit. There is a small chance that Pluto and Neptune might come near each other at some point. Despite its unusual orbit, Pluto manages to avoid Neptune most of the time thanks to gravitational forces. Gravity acts as an invisible force that pulls objects toward each other. Even though Pluto and Neptune might seem to be on a collision course, their orbits are carefully arranged due to the pull of gravity. Pluto's orbit teaches us that space is full of surprises. What initially appears chaotic can be a delicate balance of forces. By studying Pluto's orbit, scientists gain insights into the complex mechanics of our solar system. This ongoing observation and analysis are crucial for expanding our knowledge of the universe and our place in it. If Pluto and Neptune were to collide, it would be a significant event, sending shockwaves through our understanding of the solar system. While we have made progress in studying space, much remains unknown. Understanding the dynamics of Pluto's orbit provides valuable insights into how our entire planetary system functions. It shows us how the positions and movements of planets can affect the trajectories of other celestial objects. Despite the complexity of space, some scientists are concerned that Pluto could collide with Neptune. This raises questions about why such an event might happen, even though it seems unlikely. Neil deGrasse Tyson, a renowned space scientist, has expressed interest in Pluto. He believes that renaming Pluto as a dwarf planet rather than a major one like Earth is a step forward. He feels we are continually learning new things about how objects move in space. Tyson sees Pluto's unusual orbit as a sign that there is still much we do not know. He finds the mysteries of space captivating and recognizes that significant events like Pluto's renaming engage people in space science. Tyson hopes to help people stay interested in the fascinating and sometimes unconventional aspects of space. He believes it is essential to discuss how celestial mechanics work. Tyson collaborates with other scientists to warn people about the potential dangers of Pluto's unusual orbit. He focuses on the possibility of a future collision between Pluto and Neptune and how it could impact our entire planetary system. A collision between Pluto and Neptune would be an extraordinary and significant event. It could release a tremendous amount of energy and potentially break Pluto into pieces. Debris from the collision could disperse through space, affecting other parts of our cosmic neighborhood. Michio Kaku emphasizes that lessons learned from Pluto's orbit can be applied to exploring other celestial bodies, providing a framework for exploring distant worlds. He often highlights the deep connection between celestial mechanics and theoretical physics, stressing that the interactions of planets, including the gravitational dance between Pluto and Neptune, are rooted in fundamental concepts of physics. Kaku's work in theoretical physics, particularly string theory, aims to unravel these principles at their core. He suggests that focusing on the complexities of celestial mechanics, like Pluto's orbit, can provide insights into the fundamental laws of the universe. Like Tyson, Kaku has also considered the potential impact of celestial bodies and connected it to his theories about the universe. A collision between Pluto and Neptune, while significant in astronomy, could offer a unique observational opportunity, potentially contributing to our understanding of string theory and other areas of theoretical physics. Such an event could create extreme conditions of energy and gravity, shedding light on the behavior of fundamental particles and forces under intense circumstances. A key concept in string theory. The gravitational interactions and energy release from such a collision could provide a real-world context for testing these theories. Imagine the energy released from a collision between Pluto and Neptune, creating shockwaves in the fabric of spacetime, or a burst of radiation affecting nearby celestial bodies. The debris from such a collision could offer clues about the origins and composition of these planets. It would be fascinating to observe how this energy interacts with the surrounding environment, potentially providing insights into unknown aspects of the universe's inner workings. Tyson and Kaku agree that while a collision between Pluto and Neptune is unlikely, the possibility cannot be entirely ruled out. The concerns stem from the complexities and unpredictabilities of celestial mechanics, where even a small perturbation in Pluto's orbit could trigger a chain reaction leading to such an event. In conclusion, Pluto, despite its distant and small stature, continues to captivate the scientific community and the public alike. Its eccentric orbit, periodic encounters with Neptune, and the complexities of its interactions with other celestial bodies offer valuable insights into the dynamics of our solar system. The contributions of figures like Neil deGrasse Tyson and Michio Kaku emphasize the importance of studying celestial mechanics and theoretical physics to unravel the mysteries of the universe. While the likelihood of a collision between Pluto and Neptune remains low, the possibility serves as a reminder of the intricacies and wonders of the cosmos. The ongoing study of Pluto's orbit not only deepens our understanding of our solar system but also enriches our broader knowledge of the universe's fundamental laws.